In this case, for the network shown below, calculate power transfer to the load using the Norton's law. This circuit don't have the dependent source. That's why the method will be the normal. First, remove this load. How much is the load? Assume ZL, load impedance is 3 plus J4. Remove this resistance and find out a short circuit output terminals and calculate the current in the short circuit. How is this case? I will write the same. For the calculation of IN, load impedance is removed and output terminals are shorted. How is the figure? It will be something like this. Here is the source. This is at this instant we are calculating its value. 120 angle 0 degree volt is this value. There is the capacitor and this is the terminal A and B. This is A and this is B. We are shorting this terminal because 3 plus J4 is replaced by the short circuit. We are interested in this current, which is Norton's current. This is minus J10 ohm. This is plus J50. This is 10 ohm. Is it right? I will come back to you and I will discuss. I will come back to you and I will discuss which method we will use here. Anyone? Which method we will use here for this calculation? कौन सा method use करेंगे? First, nodal तो use नहीं करेंगे because here is the short circuit. Is it right? Yes, we will use the mesh analysis. Here is loop 1, here is loop 2. We'll apply the KVL to the loop 1, we will apply the KVL to the loop 2. We'll have the two equations and the two unknowns and we will find out the values of the unknowns. That is I1 and IN, and IN is our requirement. इसके अलावा कोई मेथड है? नौशाद, सौरभ, रुचिरा, रोहन, ऋषिकेश, माधुरी, चिन्मय, छाया, अविनाश. Any other method? No? Now look at this again. It is simple case. Already I have discussed many times. Whenever the short circuit is a parallel to any branch, how much is the parallel combination? 0. That's why its next figure may be something like this. This is 120 120 0 degree volt. This value. This is as it is. This is as it is, and this will be the figure. Now look at, if we are using the concepts, how the calculations will become simple. Otherwise, we have to use the two equations and then we have to use the Kramer's rule for the calculation of the current, because delta 1 upon delta and so on. We are interested in this current, which is IN, Norton's current. This value plus J15 ohm. This value is 10 ohm. And in this case, this is the I, or I will call it as I1. If we are applying the KVL here, I will write the same. Applying KVL. Applying KVL to above loop, we get. How is the case? This is plus minus, this is plus minus, or you can treat it as a single impedance. 10 plus J15, positive to negative, that is plus J, that value. Here we are traveling in the clockwise, negative to positive plus. How much is this value? 120 angle 0 degree. Then positive to negative, it is a minus. impedance is 10 plus J15, otherwise separate below secure, into its current, which is I1, and after that there is no element which is equal to 0. I will shift this value to the next side. Means in this case 120, I will convert this value to the rectangular form, plus J0, which is equal to 10 plus J15 into I1. Therefore, this I1 is equal to, this value is equal to 120 plus J0 divided by 10 plus J15. Find out this current. If we are calculating this current, I will shift this calculator to the complex mode. This is mode, complex. I will press the 2 button. Now it is in the complex. How is the first value? 120 plus 0i, और ये लिखने की भी जरूरत नहीं है 0i, divided by this value. How much is this value? Bracket start, 10 plus 15i, close the bracket, put is equal to sign. This is the real part, 3.69. 3.69 is the real part of this calculation. Then shift, this is equal to, that is minus J, because here is I, if you are able to see it, this is I. And how much is the value? I or J? This is minus J 5.53. 5.53. Is it right? This is current. If we know the current, we are interested in this current itself, because this current is same as IN. Therefore, this I1 is equal to IN, which is equal to 3.69 plus J 5.53 amperes is the Norton's current. This is the Norton's current, IN. Because this I1 is same as IN. Otherwise, इसको I1 नाम नहीं देने की जगह हमने IN दिया होता तो फिर. Now we will find out its impedance. We will remove this load resistance, and that impedance is known as Zn now. It is not Rn. It is now Zn. That is impedance. For calculation of Zn, we will remove load impedance, and all sources are replaced by respective internal resistances. Is right. This is the voltage source. How much is the internal resistance of the voltage source? इस figure में ये load को remove करना है, इस internal resistance को remove करना है. That is nothing but 0. This is one impedance. This is another. And this will be the point B. This is the point B. This is A. This is minus J10. And this is 10 plus J15. Now, this impedance is completely parallel with this. Now, directly we can find out its value, Zp or Zn, I will call it as Norton's impedance, which is equal to Zn. This branch is parallel with this, means its value will be 10 plus J15 into minus J10, Z1 into Z2 divided by Z1 plus Z2. Means 10 plus J15 minus J10. Are you getting me? Which is equal to. How much is the value? I will find out denominator first. 10, this is the real part, same. Plus J15 and minus J10. Resultant value will be plus J5. Is it right? How much is the numerator? I will multiply this using the calculator. Otherwise, you can use the oral calculations also if you are comfortable. Otherwise, I will use the start bracket because my calculator is already in the complex mode. This into this 10 plus J15. It is 10 plus 15I. Close the bracket into start bracket. This value minus. This is start bracket, it is minus 10I, close the bracket, which is equal to, this is the real part, which is 150, this is 150, and this will be the imaginary part, which is minus 100i. If it is minus j 100, this will be the numerator. Now, how much is the final value? I will find out this division. 150 minus 300 divided by this value. I will use again start bracket. This is 150 minus 100 I will close the bracket, divided by start bracket. This value 10 plus 5 I close the bracket, which is equal to. This value is 8. 8 is the real part. Then shift of is equal to, this is minus 49. This minus J14 is this value, that is Norton's impedance. Is the Norton's impedance. Now, if we know the value of Zn, then now I will write the same here. If we know In and Zn, then complicated network is replaced by Norton's equivalent network. Norton's equivalent network. How will be the network? In this case, this is impedance. When we don't know its nature, whether it is inductive or capacitive, we can write something like this. And here is the load impedance, which is removed in the first step. We will connect here. This value is 3 plus J4. This value is 3 plus J4. Ohm is the load. How much is the value of Zn, which we have calculated? The value of the Zn is 8 minus J14. 8 minus J14. This is 8 minus J14. How much is this value of this current source? The current source, that is In. In is 3.69. I will write the In here. How much is the In? 3.69. This is bracket 3.69 plus J 5.53 amperes is the In. This is In, this is Rn, and this is RL. Now here, if we know these values, then we can find out its load current flowing through the load impedance. In this case, this IL is equal to, I will write the formula first, In into Zn divided by Zn plus Zl, which is equal to, how much is the In? In is 3.69. This is 3.69 into, 3.69 plus J 5.53. This is In into Zn. How much is the Zn? This value 8 minus J14 divided by Zn plus Zl. 8 plus J14. This is one value plus Zl 3 plus J4, which is equal. First, I will find out the denominator, and then we will find out the numerator. I will use the calculator for both calculations. Denominator. How is the denominator? Start bracket. It is 8 plus J14. It is 8 plus 14i close the bracket plus start bracket. This value 3 plus J4. 3 plus 4i close the bracket is equal to sign. That is the real part. It is 11. It is 11. Is it right? This value is 11. Then shift of is equal to, that is 18i plus J18 is the denominator. 11 plus J18 is the denominator. Is this denominator? How is the numerator? In this case, start bracket 3.69 plus 5.53 I close the bracket into start bracket. This value 8 minus 14i close the bracket is equal to sign. This value is 106. It is 106.94 is the real part. Is it right? 106 is the real part. And how much is the imaginary? Shift of is equal to, that is minus J 7.42. 7.42. I will repeat this calculation because थोड़ा सा मुझे ज़्यादा value लग रहा है. I will repeat it again. This is start bracket. हाँ, that somewhere is wrong. I will repeat this calculation.
IN की वैल्यू माइनस है, -J5.5.
ये माइनस है क्या?
हाँ, यस.
It is minus. Is it right? This is minus. This is minus. Because already IN is, how much is IN? It is minus. लिखते समय मैंने गलती की यहाँ पे. This should be the minus. Is it right? This is minus value. Absolutely correct. Then here, how much is this numerator calculation? I will repeat. Is it right? Start bracket 3.69. It is 3.69. Is it right? Minus 5.53i. I will close the bracket into start bracket 8 minus 14i. 8 minus 14i, close the bracket, is equal to, its real part is, it is minus 47.9. Is it right? 47.9. Shift of is equal to, its value is minus j 95.9. Is it right? Now I will work out this division and we will find out that value. This divided by this. Now start bracket. It is minus 47.9 minus 95.9i, close the bracket, divided by start bracket 11 plus 18i, close the bracket, put is equal to sign. Its value is, it is a minus, this value is a minus 5.06. Minus 5.06 is the value of real part, and this value is, it is minus 0.43. Minus 0.43 J is its value. Is its value. इसका मतलब ये इसका resistance negative ऐसा नहीं होता है. We can convert this value to the polar form. If we are converting this value to the polar form, if I am coming back here, shift of polar. If we are converting this value to the polar form, how is the first value? It is minus 5.06, comma, what is minus this 0.43, close the bracket, is equal to sign. This is 5.07, 5.079. How much is the angle? Alpha tan is equal to, this angle is minus 175.14 degree. Something like this. This value is the IL, that is load current. Is it right? This value. But we are not interested in the load current. What is the problem? I will show. For the network shown below, calculate power transfer. We are interested in the calculation of the power transfer. And while doing the power calculation, here this P is equal to I square into R. L. I square into RL. Is it right? How is the I? We are not interested at all in the angle while calculating the power. Only we are interested in this part, which is the magnitude. This I stands for its magnitude only. Is it right? This I stands for its magnitude only. That is 5.07 its square into RL. This is load impedance. This is RL and this is XL. Load resistance, load reactance. We are interested in RL because I square into RL, not ZL. Power का formula I square into ZL नहीं है, I square into RL है. How much is RL? 3. It's into 3. This is the power. This which is equal to, that is 5.07 its square, which is equal to this value into 3. That is nothing but 77.11 watt is the power transferred to the load in this particular case. This is the power transferred to the load in this case. Is it right? This is power transfer. Anyone has any doubt regarding this? Sheikh, Naushad, Saurabh, Ruchira, Rohan, Rishikesh, Madhuri, Chinmay. Yes, anyone?
No, sir.
No, sir. No, sir.
No doubt. Okay, fine. Now this is the end of this particular theorem, which is the Norton theorem.